Hello everyone. My name is Darsini with roll number 24 PQ1A04G7, studying second year EC. Today, my topic is about stationary and ergodic random process. Introduction. In real-world communication systems, we often deal with random signals, such as noise and interference. These signals cannot be predicted exactly at every instant of time. To understand them, realize their statistical properties like mean, variance, and correlation. Two key characteristics that make such analysis possible are stationary and ergodic. Stationary means when the properties do not change with respect to time. Ergodic means when time averages represents the whole process. Let's talk about random process. A random process or a stochastic process is a collection of random variables that describes how a signal changes with time. It is written as x of t, where t belongs to capital T, where capital T represents time. Each observation over time is called a sample function or realization. Examples: noise is an amplifier, temperature variations, receiver signal strength in a wireless channel, stationary processes. Let's talk about definition. A random process is stationary if its statistical process remains constant over time. That means the process looks the same no matter when you observe it. Formally, if you shift the time axis by any amount, the characteristics such as mean and correlation remain unchanged. Example: white noise with constant mean and variance. Let's talk about types of stationarity. There are two types of stationarity. First one is strict sense stationary SSS. A process is SSS if all its joint property distributions remain unchanged with time shift. Mathematically, fx of t1, x of t2, and so on x of tn of s1 and so on xn is equals to fx of t1 plus tau, x of t2 plus tau, and so on x of tn plus tau of x1, x2, and so on xn. This is a very strong condition and a very few process truly satisfies. Wires and stationary WSS. Most engineering problems use WSS because it's simpler. A process x of t is WSS if expectation of x is equals to constant and its correlation Rx of t1, t2 is equals to Rx of t1 minus t2. That means the mean of the process does not change with time. The autocorrelation depends only on the time difference, not on actual time. We can see that the correlation is not actually depending on T1 and T2. It's depending on time difference between T2 and T1. Let's talk about examples of stationary and non-stationary process. For stationary process, the examples are white Gaussian noise, sinusoidal signals with random phase, thermal noise in resistors. For non-stationary process, the examples are space signals, where amplitude changes with time, and ramp signals, where X of t is equals to time, a signal with increasing variance. The stationary processes are easier to analyze mathematically and are used to model many real signals. Let's now talk about ergodic process. Its definition is a process is ergodic if the time averages of one realization are equal to ensemble averages of the entire process. That means that observing one sample function for a long time gives the same statistical results as observing many different realizations at one instant. Mathematically speaking, limit t tends to infinity 1 by 2t integral minus t to t capital X of t dt is equals to expectation of capital X of t. Meaning of ergodic. In practice, we can visually measure only one realization of a process. For example, one signal recorded over time. If the process is ergodic, we don't need to realize we don't we don't need many realizations. One long observation is enough to estimate its mean, variance, and correlation. That means ergodic extremely important in signal processing, communication system, and network analysis. Let's now talk about relationship between stationary and ergodicity properties. Um, let's talk about definition. For stationary, statistical properties are time invariant. For ergodic, time averages are equals to ensemble averages. Requirements. For stationary, mean and correlation should be constant over time. For ergodic, one sample path represents the entire process. Relationship is every ergodic process is a stationary process, but not every stationary process is an ergodic process. In short, ergodicity is stronger condition than stationarity. Applications in ECE. In communication systems, modeling random noise and fading channels. In signal processing, noise filtering and detection based on time averages. In speech and audio processing, statistical analysis of long-term signals. In wireless networks, performance analysis assuming ergodic fading. Control systems, system stability under random distributions. In this way, we use this in ECA. Let's summarize this. A stationary process has statistical properties that do not change with time. An ergodic process allows us to compute true averages using just one realization. All ergodic processes are stationary, but the reverse is not always true. That means all ergodic processes can be stationary, but all stationary processes are not ergodic. These concepts are fundamental for analyzing random signals in engineering, which are stationary and ergodicity. Thank you.